So in this lecture we are going to see about the derivation of numerical aperture and acceptance angle. I will tell you what is numerical aperture and acceptance angle. So this is a complete derivation, so listen carefully. If you want, you can take notes also. So let us proceed. So the title is Derivation of numerical aperture and acceptance angle. Okay, so here we go. So you know about optical fiber. Optical fiber எப்படி இருக்கும்ங்கிறது உங்களுக்கு தெரியும். So let us draw an optical fiber. So you have a core at the center and cladding at the which is immediately around the core. So let us have a cross-sectional view like this. So the center, this is the optic axis, and this is core cladding, and the corresponding refractive index are n1, n2, and this is to n2, this is again the cladding, and outside that is air n0. Okay. So as we seen in the previous lecture about the principle of optical fiber, that is theta I greater than theta C, with this condition it will undergo total reflection. So that is at the core cladding interface. Okay, so before that the light will enter into the optical fiber. So now you consider a ray that is entering into the optical fiber. Okay, so you consider it as AO. The ray is named as AO. The angle made by this ray with respect to the optic axis, that is theta I. Okay, wow. So angle of incidence theta I. இப்போ இது வந்து என்னது, இங்க வந்து refract ஆகி போகுது. It is refracting a little because this is one medium, this is another one medium. Rarer to denser medium will undergo refraction. So refract ஆகும்போது இந்த இடத்துல it forms an angle theta r. Okay, theta r என்கிற angle வந்து refracted. Now it falls at the point, இந்த point வந்து B ன்னு எடுத்துக்கோங்க, B. Now draw the perpendicular with respect to this B. Here as a whole, if you consider this one, it is 90 degree. Okay, 90 degree. This one is theta r, right? Now this is 90 minus theta r. In the angle of the 90 minus theta r, we have to come now. This is theta r. This is 90 minus theta r. So opposite angles are equal here. Is it theta r? This is also 90 minus theta r. அப்போ இந்த இடத்துல என்ன வரும், 90 minus theta r. So the angle of incidence at B is 90 minus theta r. Okay. Now with a similar angle of theta I, draw another one ray here. This is mentioned as A prime. Okay, right. Now this 90 minus theta r if it is equal to the critical angle, what about the angle of refraction here? So that is along C, BC. Okay, hope you understood this. A ray is entering into the optical fiber, that is named as AO, which is having an angle theta I, that is angle of incidence. Then it is moving inside, it will undergo angle of refraction theta R. Then it falls at the point B, 90 minus theta R. And when it is equal to this critical angle, it will undergo a refraction along BC, that is traces the path of core and cladding interface. So the core cladding interface valiya vandu idu pass aagi pogudhu, which makes an angle 90 degree. So inga vandu enadhu 90 degree, right? Okay, so whenever there is a two different medium, rarer and denser medium, there you can apply this Snell's law. What is this Snell's law? So already we have seen in the while finding this critical angle. So n1 by n2 is equal to sin theta r divided by sin theta I. Okay, so if you cross multiply this, you can have n1 sin theta I, that is equal to n2 into sin theta r. Now at the point O, we can apply this Snell's law. Okay, so here what about this? This is n0, inside it is n1, right? Now you can apply this n0 divided by n1 is equal to sin theta r divided by sin theta I. Okay, so this is sin theta I and this is theta r. So we get written like this. Now from this you can write n0 into sin theta I is equal to n1 into sin theta r. So here we can have sin theta I is equal to n1 by n0 into sin theta r. n1 by n0 into sin theta r. Now here, what about the next step? Sin theta I is equal to n1 by n0. So sin theta r can be written as square root of 1 minus cos square theta r. So that is from the since sin square theta plus theta r plus cos square theta r is equal to 1. So from this we found this value 1 minus cos square theta r. So put this as equation number 1. So at the point O, using this Snell's law, okay, so applying Snell's law, we found this value sin theta I is equal to n1 by n0 into square root of 1 minus cos square theta r. Now at the point B, so at point B also the Snell's law is applied. இந்த இடத்துல நீங்க வந்து அப்ளை பண்ணலாம். ஏன் பாத்தீங்கன்னா here this is denser medium, n1 அப்படிங்கிறது denser medium, cladding n2, that is a rarer medium. So இந்த இடத்துல Snell's law apply பண்ணலாம். So here also you can use the formula, that is n1 by n2 is equal to sin 90 degree divided by sin 90. இங்க வந்து refracted angle வந்து sin 90 degree. So incident angle பாத்தீங்கன்னா sin 90 minus theta r, sin 90 minus theta r. So இது வந்து again n1 into sin 90 minus theta r, that is equal to n2 into sin 90 degree. Okay, so hope you have copied this. So let us erase some of these things. Or we can delete this completely. Okay, so just remember the last one. So n1 into sine 90 minus theta r is equal to n2 into sine 90 degree. Okay, so this can be written as n1 into cos theta r is equal to n2 sine 90 degree. Already you know it is equal to 1, so you can keep like this. So cos theta r is equal to n2 by n1. So this is equation number 2. Now you can substitute this in equation number 1. Substitute equation 2 in equation 1. Okay, so what is equation number 1? So yes, so sine theta I is equal to n1 divided by n0 into square root of 1 minus cos square theta r. So this is the value for equation number 1. Now you can write n1 by n0. Now 1 minus, what is this cos square theta r? You can write it as n2 square by n1 square. Now by cross multiplying everything, you will get n1 by n0. The square root of n1 square minus n2 square divided by n1 square, right? So you know that square root of n1 square is again n1. So n1 divided by n0 into n1 square root of n1 square minus n2 square. So n1 get cancelled. So finally you will get the value square root of n1 square minus n2 square divided by n0. So here you know n1 is the refractive index of the core and n2 is the refractive index of cladding, n0 is the refractive index of air, right? So since n0 is equal to 1, you can write sine theta I is equal to square root of n1 square minus n2 square. Okay, so this is the value sine theta is equal to, or you can write theta is equal to sine inverse of square root of n1 square minus n2 square. So in the theta I அப்படிங்கிறது, so you can write it as theta I or theta I max. So in that maximum angle of incidence now. So theta I max, this is called as acceptance angle. This is called as acceptance angle. Why it is called as acceptance angle? So அதில் வந்து ஒரு இந்த மாதிரி ஒரு இது பார்த்தோம் இல்லையா, A prime O. Okay, so it forms an angle. So the maximum angle below which the ray enter into the optical fiber which undergo total internal reflection. Okay, so the maximum angle below which the ray enter into the optical fiber, it undergo total internal reflection. So that angle is called as acceptance angle. Maximum angle below which the ray enter into the optical fiber. Okay, here for the noise, sorry, I couldn't have a separate studio. So the maximum angle below which the ray enters to the optical fiber suffers total internal reflection. This is called as acceptance angle. Okay. Now let us see what is numerical aperture. In general, the numerical aperture is given by the light gathering capability of an optical fiber. The light gathering capability. Okay, how much light it can gather. ஒரு ஆப்டிக்கல் ஃபைபர் எடுக்கிறோம் அப்படின்னா அதில் வந்து how much light it can gather, அது வந்து கேதர் பண்ண முடியும் அப்படிங்கிறது தான் நியூமரிக்கல் அப்பர்ச்சர். கேமராவில் அப்பர்ச்சர் வேல்யூ இதெல்லாம் பற்றி கேள்விப்பட்டிருக்கீங்களா? இட்ஸ் ஓப்பனிங், ஹவு த ஷட்டர் இஸ் ஓப்பன்ட், அந்த அப்பர்ச்சர் இது வந்து ஓப்பன், அது ஓப்பனிங்கை தான் சொல்லுவோம். ஸோ அது மாதிரி இதில் வந்து அந்த ஓப்பனிங் how much it can be gathered. So it will vary for different optical fiber because there are different types of optical fiber. அதனால் the numerical aperture value வந்து என்ன ஆகும்னா vary ஆகும். So it is also given by NA is equal to sin of acceptance angle, அதாவது sin theta I max. So these notations may be different in the notes in the books, so you can follow some same notation. Okay, so sin theta I max அப்படிங்கிறது தான். அப்போது ஆல்ரெடி உங்களுக்கு தெரியும் theta I maxனா என்ன அப்படின்றது. ஸோ sin inverse of square root of n1 square minus n2 square, இதுதான் வந்து என்னது acceptance angle. So if you take the sign of that sin inverse cancel ஆகிடும். So finally you will get square root of n1 square minus n2 square. Okay, so this is the value for numerical aperture, square root of n1 square minus n2 square. Okay, so this is one and this is another one, acceptance angle. Okay, so this is the our motto in this derivation. Hope you have understood everything. ஸோ ரெண்டு இடத்துல வந்து நம்ம என்ன யூஸ் பண்ணுறோம் அப்படின்னா ஸ்னெல்ஸ் லா யூஸ் பண்ணி சிம்பிளிஃபை பண்ணி ஃபைனலி வி ஆர் ஃபைண்டிங் தி acceptance angle, ஆல்சோ நியூமரிக்கல் அப்பர்ச்சர். இப்போது ஒன் மோர் திங், த ஃப்ராக்ஷனல் இண்டெக்ஸ் சேஞ்ச் அப்படின்ட்டு ஒரு வேல்யூ இருக்குது. ஃப்ராக்ஷனல் இண்டெக்ஸ் சேஞ்ச். So it is given by delta. So this is given by the definition, difference between or the refractive index difference between core and cladding divided by refractive index of core. Okay, right. So இப்போ refractive index of core உங்களுக்கு தெரியும் n1 minus n2 divided by n1. Okay, so this is the fractional index change. So I can write it as n1 into delta is equal to n1 minus n2. Okay, now what is the value for numerical aperture? NA is equal to square root of n1 square minus n2 square. So இப்போ mathematical இதுபடி a square minus b square, that is a plus b in a minus b. Okay, so n1 plus n2 into n1 minus n2. சரிதானே? Okay, so if n1 is equal to n2. இப்போ n1 minus n2க்கு என்ன யூஸ் பண்ணிடலாம்னா n1 into delta. So you can write here n1 plus n2 இது ரெண்டுமே சேம் அப்படின்னு வச்சிங்கன்னா n1 கன்சிடர் பண்ணிக்கோங்க. ஸோ 2n1 n1 minus n2 அது n1 into delta. So you can write as square root of 2n1 square delta. So finally we'll get n1 square வந்து n1 வெளியே வந்துருமா. So n1 into square root of 2 delta. So this is the relation between fractional index change and numerical aperture. Okay, so this also you got to derive in this. In addition, condition for propagation of light. So condition என்ன அப்படின்னு பார்த்தீங்கன்னா theta I should be greater than theta C. Critical angle உடைக்கும் angle of incidence வந்து அதிகமாக இருக்கணும். So that is the main thing. So sin theta I should be greater than sin theta C அப்படின்னு sin of angle of incidence இதுவும் வந்து அதிகமாக வந்து இருக்கணும். So this is the condition for propagation of light. So let me show the condition. Okay, so here it is. Okay, so அது வந்து condition for total non-reflection. So here this condition for the propagation of light in optical fiber, so it is different. Theta I is less than theta naught. Theta naught in the sense we have used theta I max, அதாவது acceptance angle உடைக்கும் லெஸ்ஸராக இருக்கணும் அப்படின்னா தான் இது வந்து நடக்கும். ஸோ சைன் எடுத்திங்கன்னா sin theta I that should be less than sin theta naught. Okay, so sin theta I அப்படிங்கிறது it should be less than the square root of n1 square minus n2 square, which is nothing but the numerical aperture value. Okay, so these things you should know. இந்த இடத்துல வந்து நம்ம ஞாபகம் வச்சுக்க வேண்டியது இந்த condition theta I less than theta naught. So taking the sin theta I less than sin theta naught, and again it is less than the numerical aperture value. Okay students, I hope you have understood this. So a big thanks for watching. So meet you in another one lecture. Thank you all.